Now, in the historical reconstruction of neutral theory, we have, as you may remember, in a book that I wrote, I emphasized exclusively the work of Moto Kimura and his school, claiming that neutral theory as developed by Moto, as originated by Moto, I should say, I'm talking about the origin of neutral theory, originated out of a conflict about the nature of standing variation in populations, namely the classical balance theory. And my claim was that the origin of this was, in fact, on the part of Moto, a need to cope with the observation that there was a huge amount of genetic variation within populations without having to accept the Dobzhansky school view that that variation was evidence of natural selection. Now, Dobzhansky had a very odd view of two aspects of the evolutionary process which didn't quite work. Dobzhansky's view was that this variation, which one could observe in a natural population of organisms, he never observed it, he just imagined it was there from experiments which were rather ambiguous. But his claim that there was a lot of variation, his claim that that variation was in fact itself a product of natural selection, i.e. that it was balanced by selective forces with superiority of heterozygotes and so on. That's why it was there. What he didn't seem to notice, or at least never made explicit, is the contradiction, or apparent contradiction, between the claim that the standing variation in a population is balanced and the claim that it is the basis for this process. Because it's really balanced, it isn't going to go anywhere. I mean, the whole point about balanced polymorphism is that it's balanced, it's in equilibrium. But the Darwinian theory requires a transformation of that variation in frequency space until you get down here. And if you were a balance theorist, you would have to separate the process of the maintenance of the variation on which you claimed evolution was going to be built, and a different process which would then take that variation at some moment and transform it in time and frequency. You would have to suppose one of two things. Either that you could say, well, the balance theory proves, if I believe in it, that this variation is of some significance to the physiology and metabolism of the organisms, because if it's balanced, that means there are different fitnesses, and if there are different fitnesses, then it matters to the organism. And then along comes and it's balanced, but then some change occurs in the environment or in the world such that one of the homozygotes now, instead of being less fit than the heterozygote, becomes more fit and sweeps through the population. That's one thing you could say. I'm not saying that's what he did. That's one thing.
Ernst Mayr, of course, considered his primary contribution to evolutionary biology to be the concept of a genetic revolution, because he believes all the balance, all the homeostasis, everything working on the gene pool, and you need a genetic revolution, which he never explained.
Right. Okay. So it's a genetic revolution. But it doesn't have to be a revolution. It could be as small as simply one homozygote now creeping up above the heterozygote and taking over. Dobzhansky never dealt with that. He really didn't. He didn't appreciate the problem. The alternative is, you could say, that environment changed in such a way that a lot of the formerly selected variation was no longer selected, became neutral, and then you could have an evolutionary process by drift. But you at least had to assert something, not necessarily revolutionary, but a change in the process between the origin. The origin was mutational, but that nobody cared about that. This developmental process was different, and I want to emphasize that. That's the balance school, and that's an inconsistency in the balance school, or at least a missing part of the balance school. You can't simultaneously say it's balanced and say that it's a basis of evolution. The neutralist school, however, is the reverse. The neutralist school says that the very same process which is productive of the variation inevitably results in some movement through the space to a change at the end. That is to say, in Moto Kimura's papers, in one paper, he talked about polymorphism as a stage in the evolution of but that's got it upside down in a sense for self-inflationary reasons. The theory of neutral polymorphism due to Sewall Wright from the very beginning intrinsically was a theory of both variation and evolution, because the dynamic of a random process includes the fact that the gene frequency is undergoing a random walk and eventually falls off the edge and becomes fixed, as all random walks in one dimension do. That is to say, you don't require another process in addition to the process that molds the variation at any particular instant if you're a neutralist. Because neutrality is a theory simply of random walk, which includes both variation and eventual fixation. So in that sense, the neutral view of the matter, which we owe, and we owe all of that to Wright, to say I regard variation as a stage in the process of evolution, well, you can if you like, if you're trying to explain evolution in the first place, but I could turn it upside down and say I regard evolution as the inevitable consequence of variation. I could take the neutral variation as the fundamental point about the world and say, oh, and incidentally, if you believe that, then organisms are going to evolve. And it's a very important change in point of view, because an adaptive theory has this notion built into it somehow from Darwin that evolution is an adaptive process and that the variation is an intermediate stage of it, whereas the random theory turns out upside down. So I don't have to think anything about adaptation or changes in the world. Any random process will go to fixation someplace, and it'll almost certainly be different from what you started with. And I think that's so that it's very important to distinguish those two. Now, in the historical situation of the development of neutral theory, I, concerned with this problem, told the story of neutral theory from this standpoint. That is to say, not that I was about, and by the way, Edna, there I disagree with you. The experiments done by hubby and me were not part of the program of the balance theory. I was never a balance theorist. Being rebellious, anything Dobzhansky said I disagreed with. I can honestly say, I think, and this is not post hoc revisionism or something, that the purpose of those experiments was to ask the question in a completely neutral way, how much variation is there? They were meant to be a solution to that problem without a commitment to what the answer would be. And in fact, I have to tell you that I was very surprised by the answer. Underneath, I thought probably there wasn't much variation. So I just want to make that historiographically clear. And I don't think anywhere in our papers did we then say, this is a manifestation of the balance theory. On the contrary, we indicated that there would be real problems because you'd have a load problem. Then we said, of course, I mean, especially in my book, I said, but of course you can solve the load problem by not being so naive about it, and then back and forth and back and forth. But I think it's true.
No, at the end of Lewontin and Hubby, you go through the three alternatives, and the heterotic alleles come out smelling sweeter than the other two.
Do they? Okay.
None of them smell sweet.
Yeah, okay, fine, fair enough. And let me say that in retrospect, I still think for that set of data, it's sweeter because of the observation of the similarity in gene frequency distributions in different, quite distant populations. That would be almost impossible to explain on neutralism. Right. So I think, but again, that's after the fact of the observations. Right. It was not part of the program. I think it's important. For example, had we found that there was tremendous diversity from population to population in the gene frequencies, I would have come to the other conclusion. Perhaps incorrectly, but that's